Flasking and packing. Classification of plastics, according to the following features. 1. By the degree of rigidity. Hard, for bases of prostheses and their restoration. Soft, for boxing tires or as a soft lining under the hard base. 2. By the temperature polymerization. Cold curing. Hot curing. 3. By the presence of the dye. Pink. Colorless. Components of plastic. 1. Powder, polymethylmethacrylate, beads or granules. Initiator, benzoyl peroxide. Pigments, colorants. Opacifiers, titanium or zinc oxides. Plasticizer, dibutylphthalate. Synthetic fibers, nylon or acryl. 2. Liquid. Monomer, methylmethacrylate. Inhibitor, hydroquinone. Cross-linking agent, ethylene glycol of dimethacrylic ether. Flasking and packing. Flasking is a device for the polymerization of plastics during manufacturing of the dentures and casting duplicate modules of the jaws. Flask components. 1. Lower part, base, with grooves. 2. Bottom of the base. 3. Upper part with protuberances. 4. Cover. Flasking and packing. Flasking methods. 1. Direct. 2. Indirect, or revere. 3. Combined. Plastic molding methods depending on the equipment used in the manufacture of removable prostheses. First. Compressive pressing method. Methods of plastering of gypsum models and flask modifications. Reverse method of plastering. At the base of the flask, only the plaster model remains. Artificial teeth move to the upper part of the flask. Immerse the model for a few minutes in the water. The gypsum mixed with water, the upper part of the flask is filled with it, and the base of the model is placed in it up to the artificial gum. After hardening, the gypsum is cut off at the level of the upper edge of the flask, and the waxed base with the teeth and artificial gum remains free of gypsum, rising above the edges of the flask. The upper part of the flask with the plastered model is placed in cold water. Then cover it with a base, remove the cover and fill the base of the flask with plaster in small portions, lightly tapping the table to remove air bubbles. The base of the flask is filled with plaster to the brim, the cover is applied tightly, and excess gypsum is removed. After that, the flask is placed in boiling water to soften the wax. The gypsum is smoothed at the level of the flask sides and after crystallization is placed in cold water for a few minutes to prevent the gypsum from joining the new portion. After pulling the upper part of the flask out of the water and shaking it, place the base of the flask on it and remove the lid. Knead the plaster and fill the base of the flask in small portions. After crystallization of the gypsum, the flask is immersed in boiling water to melt the wax for 7 to 10 minutes. The melting of wax from the flask can be judged by the appearance on the surface of the water of its traces. The flask is then removed, separated with a plaster knife and placed on a wax grid. Boiling water is poured over both ends of the obtained gypsum mold until complete removal of wax. In order to prevent the connection of plastic with gypsum of the obtained molds, they are covered with insulating varnish, Isocol, algoplin. Insulating varnish is applied evenly over the entire surface of the plaster module with a brush, avoiding the varnish on the artificial teeth. If there is excess insulating material, it is removed with a brush. Plastic molding methods depending on the equipment used in the manufacture of removable prostheses. Compressive pressing method. Methods of plastering of gypsum models and flask modifications. Direct method of plastering. The model, artificial teeth and clasps remain at the base of the flask. The model is separated from the articulator, cut its base so that the edge of the base of the flask is slightly above the level of artificial teeth. Some parts of the plaster teeth with clasps are cut to facilitate the shoulder of clasps plastering. Moisturize the model, knead the plaster, and fill the base of the flask. The model is immersed in a plaster base to the bottom of the flask. From the extruded gypsum, a roller is formed above the teeth, covering the vestibular surface, the cutting edges of the frontal teeth and the chewing surface of the posterior teeth. The palatal surface of the upper teeth and the lingual surface of the lower teeth are not covered with plaster. The plaster roller must be sufficiently strong, smooth, without undercuts. Clean the edge of the base of the flask from gypsum after it hardens. Immerse for a few minutes in cold water to isolate from another portion of gypsum. Impose the upper part of the flask without cover. It is filled with liquid plaster, constantly shaking the flask to prevent the formation of bubbles, and tightly closed with a cover. Excess gypsum is removed. Methods of plastering of gypsum models in Flask. Plastic molding methods depending on the equipment used in the manufacture of removable prostheses. Compressive pressing method. Methods of plastering of gypsum models in Flask. Modifications. Combined method. The plaster model and the front artificial teeth remain at the base of the flask, and the chewing teeth move to the upper part of the flask. The method is used in the placement of anterior teeth as in the short bite anterior tooth. The base of the flask is filled with plaster and the prepared plaster model is placed into it. The front teeth, placed without artificial gums, are covered with a plaster roller, as in the direct method, and the posterior teeth are not covered by gypsum, as in the reverse method of plastering. The base of the flask is placed in cold water, the upper part of the flask is applied without a cover, fill with liquid plaster and close the cover. After the plaster hardens, the wax is melted. Combined method. Disadvantages. 1. If the parts of the flask are not tightly connected, plastic is released, which can lead to an increase in the height of the bite due to an increase in the thickness of the basis of the prosthesis. 2. Artificial teeth move vertically relative to the prosthetic plane. 3. In case of violation of the occlusion, the resistance of the prosthesis to its chewing effectiveness deteriorates. 4. Deformation of the plaster mold may occur in violation of the contours of small parts of the prosthesis, the shape of the basis of the prosthesis is distorted. 5. If the polymerization mode of plastics is violated, porosities are formed. Gas, the presence of monomer steam, granular, with a lack of monomer and compression porosity, due to insufficient pressure. At present, the compressive pressing method is considered to be outdated, which does not provide the required quality, and another method came to replace it, injection casting, in which the prepared material is introduced into a pre-closed flask through the injection channel. Plastic molding methods depending on the equipment used in the manufacture of removable prostheses. 2. Injection casting pressing method. The method allows reducing the content of monomer in the bases of prostheses. Injection casting pressing method, compared with compressive pressing method. Advantages. 1. All excess plastics remain in the casting channel. 2. The plaster formed does not experience a deforming effect. 3. The details of the base part of the prosthesis correspond exactly to the specified parameters. The most promising technologies of cold pressing, which are successfully used in European countries. Injection pressing method, Therese Kulzer, Germany. Cold polymerization method, Vertex, Holland. Cold polymerization method, Drava, Germany. Stages of plastic polymerization. 1. Wet sand, granular. 2. Viscous, long and short stretching threads. 3. Paste-like. 4. Rubber-like. 5. Solid. Polymerization mode. The polymerization process is aimed at converting plastic from plastic to solid. Monomer is a polymer mixture. It can harden under normal conditions, at room temperature, but this will take considerable time. To speed up the polymerization process, it is necessary to increase the temperature. After pressing, 3000 psi, both parts of the flask are tightened with a special retainer, biagal. The flask is immersed in water at room temperature, and, gradually, within 45 to 60 minutes, the temperature increases to 80 degrees Celsius. Then, from 80 degrees to 100 degrees, for the next 45 minutes. At the same time, as the temperature increases to 680 degrees Celsius, the polymerization process proceeds smoothly, At temperatures above 65 degrees Celsius, the residual benzoyl peroxide quickly splits and the polymerization rate increases. During this period, due to the polymerization of the monomer, the mass decreases in volume. When reaching 65 to 68 degrees Celsius, the mass begins to increase in volume due to thermal expansion. Polymerization is a chain radical process, and an increase in temperature leads to an increase in the molecular weight of the polymer. This may lead to changes in physicochemical properties of plastic, strength, etc. Therefore, in order to achieve optimum molecular weight, the final stage of polymerization is carried out at a temperature of 100 degrees Celsius, maintaining exactly 30 to 45 minutes. Then the heating is turned off and the flask is in the water until it cools completely, slow cooling, for 40 to 60 minutes. Porosity of plastics. 1. Gas porosity. It is caused by the evaporation of the monomer inside the polymerization molding composition. This happens in violation of the mode of polymerization. When lowering the flask into boiling water. When heating a form with a large amount of mass due to the complexity of removing excess heat from it, which develops as a result of the exothermicity of the polymerization process, observed in the thick plastic base. Porosity of plastics. 2. Porosity of compression. Occurs with insufficient pressure, when the mass is formed, as a result of which separate parts of the form are filled with the molding material and voids are formed, usually observed in the terminal, thin parts of the product and between artificial teeth. Porosity of plastics. 3. Granular porosity. It occurs as a result of a lack of monomer in those areas where it can evaporate. Most often, the monomer volatilizes from an open vessel, where the plastic dough matures or when it is in check. Looks like chalk streaks or spots.